All right, moving on to example number 9, we are deriving secant of x squared plus 1. So this problem is no more complicated than the last one. The problem just comes down to knowing exactly how to derive secant. I encourage you to practice these weird trig function derivatives as much as you possibly can. You can check out our trig function derivatives drill on the homepage of this course, or if you just need a quick reference to some of these derivatives, check out one of the buttons on the right-hand side of this card. So how do we go about solving this one? We need to identify the outside function. Outside function in this case is obviously going to be secant. The inside function is the thing on the inside of the parentheses. So this gives you x squared plus 1. That's your inside function. How do we derive it? Okay, so again, the problem comes down to knowing what the derivative of secant is. If you remember, it is going to be secant of blah times tangent of blah. Okay? So basically one trig function derived into a product of two different trig functions here. So the derivative of secant is secant x tangent x, but we have to plug in the original function, this x squared plus 1, into both. All right? All right. And that's just by nature of the derivative of secant. You're literally taking the inside function, this x squared plus 1, and plugging it into the derivative. The derivative in this case of secant is secant x times tangent x, so that's what you're plugging it into. Now you multiply by the derivative of the inside, and that's simply 2x. The problem is done at that point. Again, the challenge was just knowing how to derive secant and knowing how to handle this inside bit here. Okay, so that's example 9.